Good morning, dear students. Today I will discuss some questions from miscellaneous exercise. But before that, I will discuss what we got so far. First, this is number one. We already got these things. I'm just discussing once again. If A is subset of B, then A intersection B is equal to the smaller set and A union B equal to the bigger set. Next, number 2. For any set A intersection universal set. Universal set is always the largest set, biggest set. A intersection U is the smaller set and A union U is equal to the bigger set. Next, definition of subset. If X belongs to A implies X belongs to B, अगर ए में होना ये मीन करता है कि वो बी में भी है. A student of class 11 of KV Porchar implies that he or she is a student of KV Porchar. So Porchar is the bigger set, class 11 is the smaller set. X belongs to A implies X belongs to B. That is, if X is an element of A, it implies X is also in B. It means A is subset of B. Just consider this, think in this way. If X is a student of class 11 in KV Porchar, then X is also a student of KV Porchar. So here student of class 11 is the smaller set, KV Porchar is the bigger set, so A is subset of A. So if X belongs to A implies X belongs to B, then A is subset of B. Next, number 4. If A is subset of B and B is also subset of A. If A is subset of B, B is subset of A, then A equal to B. The set A is equal to set B. If A is subset of B and B is also subset of A, then A is equal to B. Next, number 5. If we take union of two sets, suppose A union B, then A union B is superset of A. That is, A and B both are subset of A union B. The set A is a subset of A union B. The set B is also a subset of A union B. A, B subset of A union. A union B is always bigger than A and B. And if we take A intersection B, A intersection B is subset of A as well as B. A, B both are subset of A union B. A union B is the bigger than A and B, and A intersection B is subset of both A and B. Next, number 6. So very important, very important. This is actually a theorem, you can say, and you have to remember A minus B is equal to A intersection B complement. A minus B is equal to A intersection B complement. Now let us prove this by using Venn diagram. Suppose this is the set. I have taken two sets A and B. First I have marked the set A. This is the set A. I have marked this by A. Okay. And you can say this is B complement, means not B. I have marked outside B. This is the set B. I am marked outside B. This is the set A and this is B dash. And what is common to these two set A and B dash? Common part, common part of A and B dash is this A and B dash, and this is the common part of A intersection B dash. Now we know this is the set, this is A intersection B dash, and we know this is the set A minus B. From A, if we remove the common part, which is also in B, if we remove this part, we will get A minus B. This is A minus B, and this is A intersection B dash, and this is A intersection B dash, and hence we can say, we can conclude A minus B is equal to A intersection B dash. It's a very important and useful theorem. Next, let us start with this particular questions. These are given in miscellaneous exercise of NCERT book. Let us start with this. Show that for any sets A and B, A equal to A intersection B union A minus B. Number 1. Let us start with the right hand side. A intersection B union A minus B. A intersection B union A minus B is A intersection B dash. Just now I have written A minus B is equal to A intersection B dash. Now we got distributive property. Using distributive property, this equal to, we can write A intersection B union B dash. Now I am writing here the distributive property A intersection B union C. Sorry, let me write A intersection B union C is equal to A intersection B union A intersection C. Okay, A intersection B union C equal to A intersection B union A intersection C. This is distributive property, and you can see here also, you compare this line with this A intersection B union A intersection B dash, A intersection B union A intersection C is equal to A intersection B union C. B union C. Just using this property, this is distributive property, and using this property we get this equal to A intersection B union B dash. A intersection B union B dash. I have used this property. You can see this is the distributive property. And using distributive property, I got this. Now, B union B dash is equal to the universal set. A set and its complement B dash. If you take their union, you will get the universal set. Now, U is the biggest set. It's bigger than A. It's bigger set, smaller set. A is subset of U. The common part intersection will be the smaller set. It's equal to A, and this is equal to the left hand side. This is question number 1. Okay. Next, let us try question number 2. Let us start with the left hand side. You can start from any side. You can start from left hand side or from right hand side. We have to prove A intersection B minus A equal to A union B. So let us take the left hand side, A union B minus A. What is B minus A? Just now we got the definition. I'm writing here A minus B is equal to A intersection B dash. Just now we got this theorem, A minus B is equal to A intersection B dash. By using this, B minus A equal to B intersection A dash. B intersection A dash. By distributive property, A union B intersection A union A dash. Now A union B intersection A union A dash is the universal set U. Now, if we compare these two sets, this is the bigger set, this is the smaller set. U is always the biggest set. A union B must be a subset of U. This is bigger set, this is a smaller set. If you compare, it's the smaller set, their intersection will be the smaller set. A union B, and which is equal to the right hand side as A union B is subset of U. You have to write the reason B minus A equal to why you have written this. This is the distributive property. You have to write by distributive property. By distributive property, etc. etc. This is question number 2. Now, let us move to third part. Third question. A union A intersection B is equal to A. Let us take the left hand side. A union A intersection B. We have to prove this equal to A. We'll use the distributive property again. A union A union A intersection A union B. What is A union A? A union is, it important law is A intersection A union B. Now, before the beginning of the questions, I have written some, I've discussed some properties what we got in earlier classes. You can see A B, both are subset of A union B. This is the bigger set, this is the smaller set, and A intersection B is subset of A union B. Here A union B is superset of A. A is subset of A union B. So here A is the smaller set, A union B is the bigger set, their intersection is A. You can write the reason as A is subset of A union B. Their intersection must be the smaller set. Is equal to A, right hand side. Next, let us write the fourth question. A intersection A union B is equal to A. I think now you can do this question by yourself. Let me do it. Left hand side, A intersection A union B. A intersection A union B by distributive properties. A intersection A union A intersection B. And this is A, it important law, union A intersection B. Now, A intersection B, A, we know A intersection B is subset of A. This is the bigger set, this is the smaller set. Their union must be the bigger set. As A intersection B is subset of A is equal to A. Okay, so these questions are given in NCERT book, and what we have done here, we have used the properties of sets. So first read the properties carefully and then apply the properties in solving these questions. Now let us start this particular question, which is also given in NCERT book. Show that if A is subset of B, then C minus B subset of C minus A. Now, how to prove a set is subset of another set? Just now I have written, just today I've shown some the properties of set. I've discussed with some properties of set. There you got, if X belongs to A implies X belongs to B, then A is subset of B. And this is the way to prove a set is subset of another set. How to prove A is subset of B? We have to take an element X from A and we have to show X is also an element of B. X belongs to A implies X belongs to B. Then A will be subset of B. Here we have to prove this set C minus B is subset of C minus A. How to prove? We have to prove X belongs to C minus B implies X belongs to C minus A. X belongs to C minus B implies X belongs to C minus A. Let X belongs to C minus B. Now the by definition of difference of sets, X belongs to C, and you can check the definition of C minus B. X belongs to C minus B means X belongs to C and X does not belong to B. This is definition of C minus B. X belongs to C minus B means X belongs to C and X does not belong to B. Now what is given? A is subset of B. A subset of B means this is the set A and this is the set B. You can think again, you can think in this way. A students of class 11 of KB Borchar. B students of KB Borchar. This is the bigger set. Students of KB Borchar. Students of class 11 of KB Borchar. A is subset of B. Now X belongs to C and X does not belong to B. Does not belong to B means X is not in the bigger set. X is not a student of KV Borchar. If X is not a student of KV Borchar, X cannot be a student of class 11. He is not a student of KV Borchar, not in the bigger set. So he cannot be in the smaller set. X is not a student of KP Borchar means he is not a student of any class of KP Borchar, so he cannot be student of class 11. So X does not be means X does not belong to A. As A is subset of B, X is not in B means X is not in A. Now X belongs to C and X does not belong to A means X belongs to C minus A. This is the definition of difference subset. If X is in C and X is not in A, that is X is not common to C and A, so X will be in C minus A. So what we have proved? X belongs to C minus B implies X belongs to C minus A. Just use the definition. X belongs to A implies X belongs to B. Then A is subset of B. Exactly in the same way, X belongs to C minus B implies X belongs to C minus A. So C minus B is subset of C minus A. Therefore, okay. Let us try another problem from NCERT miscellaneous exercise. Let A, B and C be the sets such that A union B equal to A union C and A intersection B equal to A intersection C. Show that B is equal to C. What is given? A union B equal to A union C. A intersection B is also equal to A intersection C. To prove B equal to C, here we have to prove properties of sets. By using properties of set, we can prove B equal to C. So let us start with the set B. Set B. B equal to, we can write A union B intersection B. Now we know B is subset of A union B. Actually both A and B are subset of A union B. Particularly the set B is a subset of A union B. It's the bigger set, smaller set. B is a subset of A union B and their intersection must be the smaller set B. That's equal to B. Now by distributive property. Distributive property. A intersection B union B intersection B. I told you how to remember this. You remember in this way: A plus B into C is equal to A into C plus B into C. Just you remember this and you can easily apply distributive property. You can see A union B, A plus B dot C. So A dot C, A intersection B, union B dot C. I've used this property. Remembering this, you can also apply the distributive property. You can write here by distributive property. But you cannot write this because this is distributive property of multiplication over addition, and this is distributive property of intersection over union by distributive property. I've written just to explain just how can you remember easily this property. For that only I have written this by distributive property. A intersection B. Now just given you can see A intersection B is equal to A intersection C. So let me write this equal to A intersection C, and this is B intersection B by idempotent law is B. This is given, you can write given. Now again, let us again apply distributive property. A union B intersection C union B. A union B intersection C union B. Again, you can see given A union B is equal to A union C. So we can write A union B equal to A union C intersection C union B. C union B equal to, by using commutative property, we can write a B union C. Again using distributive property, A intersection B union C. You can see this will be A intersection C in A union C intersection B union C. Distributive property. A union B equal to, you can see A intersection B is equal to A intersection C. Let me write this equal to A intersection C. And what is their union? Because A intersection C is subset of C. This is a smaller set, this is the bigger set, and this must be equal to C. This is the bigger set, sorry, smaller set, this is the bigger set, smaller set, bigger set, union must be the bigger set, so C. Okay, so what we have proved, the set B is equal to C. Now you have to write the reasons using distributive property, because this is subset of this is given, you have to write the reasons here. Okay, so this is the way how you can prove B equal to C if these two are equal. Okay, next let us take another question. Show that A intersection B equal to A intersection C need not imply B equal to C. If these two sets are equal, A intersection B is equal to A intersection C, it does not imply that B equal to C. Now, to prove this is not true, we can prove by taking an example. To disprove something, we can show by taking an example, but we cannot prove something by taking an example. Suppose we have to prove that this A intersection B equal to A intersection C implies B equal to C. In that case, we cannot take example. For to disprove something, to show this is not true, we can take help of an example. Now let us take A equal to, let me write A equal to 1, 2, 3, 4. B equal to, let me write 1, 2, 7, 8. And C equal to, let me write 1, 2, 5, 6. Now what is A intersection B? What is the common elements of A and B? A intersection B is equal to 1, 2. A intersection C is equal to, again 1, 2. 1 2 1 2 1 2, A intersection B is 1 2, A intersection C is 1 2. So A intersection B is equal to A intersection C. Therefore both are equal to 1 2. But are B and C equal? B equal to 1 to 7 8, C equal to 1 to 5 6. So but B not equal to C. So what we have proved, A intersection B equal to A intersection C, A intersection B equal to A intersection C need not implies, although these two are equal, but B and C are not equal. Okay, so there are some more problems given in the NCERT book. I will discuss some more problems tomorrow, but do revise properly what we have studied so far. Read thoroughly, read carefully, try to remember the properties, and just try to use them in solving problems. Tomorrow I will discuss some more problems given in the NCERT book. Thank you.